What if the very first humans to leave Africa didn't follow the riverbanks or the fertile plains like we were taught? What if the true gateway, the original launchpad of human history, wasn't the Nile, but Yemen? You've heard of Mesopotamia, Egypt, the Indus, civilizations that bloomed along rivers, carved their gods into stone, and left behind ruins we still worship today. But long before those cities rose, before language had names, something far more ancient happened, something almost no one talks about. Because buried deep beneath the mountains and deserts of Yemen is evidence that rewrites the entire map of human migration. 60,000 to 70,000 years ago, small groups of early Homo sapiens crossed from the Horn of Africa into what is now southern Yemen, not by accident, not by storm, but through one of the narrowest ocean crossings on Earth, Bab el-Mandeb, just 10 miles of water. But it marked the beginning of everything. This wasn't a detour, it was the first leap into the unknown. And now, genetic evidence confirms it. In the DNA of modern Yemenis, specifically in rare mitochondrial haplogroups like L6 and early branches of M and N, we found traces of those first migrants. These aren't diluted remnants. These are direct maternal lines, preserved with almost no interruption. This makes Yemen one of the only places on Earth where we can still see unbroken the genomic fingerprint of that original journey. No monuments, no epic poems, just a genetic trail. Silent, stubborn, alive. So here's the question no one dared to ask. What if Yemen wasn't just a bridge out of Africa, but a sanctuary? A place where early human lineages didn't just pass through, they stayed, adapted, and held on to their identity across tens of thousands of years. Because in this forgotten corner of the Arabian Peninsula, something extraordinary happened, and we're only just beginning to unlock it. But to understand why Yemen's DNA is like no other, we must go deeper. Because while many moved on, one branch didn't. It stayed, it evolved, and it hid something the world is only now starting to see. That something carries the name R0A, not a dynasty, not a monument, a mitochondrial code passed only through mothers that refuses to vanish. Modern geneticists call it the Arabian marker, but its story begins long before Arabia had a name. Somewhere between 25,000 and 30,000 BCE, during the tail end of the last glacial maximum, a maternal lineage rooted itself into southern Arabia. The world was colder, sea levels were lower. The Red Sea is a narrow gate between continents, and through it early humans moved, some forward and some inward. What shocks scientists today isn't just the age of R0A, it's where it survived, not in Europe, not in Anatolia, but in Yemen and in the highlands of the Horn of Africa. In fact, Yemenis today carry the highest frequency of R0A ever recorded, over 20% in and some populations. This isn't background noise. This is a loud genetic fingerprint of Ice Age endurance. When the climate turned hostile, when deserts swallowed rivers, when new waves of Neolithic farmers swept across the Levant, R0A didn't fade. It was held. Through millennia of isolation, tribal endogamy and mountain strongholds, this maternal signature remained. And it wasn't alone. Buried in the same genomes, researchers have now found early sub-branches of haplogroup M, once believed to have moved straight into Asia. Yet here they are, in Yemen, suggesting something far more complex. Yemen wasn't just a stepping stone. It was a retention zone, a place where early lineages paused and then stayed. What does this mean? It means some of the oldest maternal lineages outside Africa are not in Europe or Asia. They are in Yemen. Not diluted, not forgotten, preserved like a fossil, but living. But this lineage wasn't the only one to survive the ice, because while R0A was carved into stone through isolation, another legacy arrived not in silence, but with sails. And it didn't come by invitation. It came by wind, and by war, and by trade disguised as chains. From the 8th century all the way into the 19th, across over 1,000 years, Yemen's coastal harbours became crossroads in one of the most haunting human movements in history, the Arab slave trade. It's a history often denied in the textbooks, but the genomes remember. Because when scientists sequenced Yemeni mitochondrial DNA, that's the DNA passed only from mother to child, they found a staggering truth. Nearly 30% of maternal lineages in regions like Al-Hudaydah and Hadramaut belong to haplogroups L0, L2 and L3, lineages deeply rooted in sub-Saharan Africa. These weren't just migrants, they were enslaved women, taken from Sudan, Ethiopia, Somalia and beyond, some forced across the Bab el-Mandeb Strait, others traded inland across Arabia. What followed was not just assimilation, it was absorption. And it left a genetic echo that refuses to be silenced. Under Islamic law, children born to enslaved women were legally free. Their status did not carry the chains of their mother. And so, a paradox was born. Mothers from Africa, whose descendants would grow up Yemeni, speak Arabic, inherit land, lead tribes. The men who owned them, their DNA is missing. In the paternal line, the Y chromosome, this African story disappears. Scientists found it again and again in study after study, from 2008 to 2024. African mitochondrial DNA remains strong, while African Y DNA is nearly absent. What does this mean? It means this was a gendered migration, not a union, not a blending, but a one-sided insertion into society, where women remained in the family and men vanished from history. And you can hear it still today, in the rhythm of the music from Mukalla, in the spices of Hudaydah's stews, in the whispered Swahili woven into the dialects of Yemeni coasts, but in the bloodline, only the mothers stayed. Yet in the Y DNA, these women vanish, replaced by a single dominating lineage. And that lineage, it doesn't just dominate, it erases. It speaks of tribal power, of conquest, and of the men who claimed Arabia for themselves. That lineage, J1, specifically J1P58, doesn't just appear in Yemen's male genome, it rules it. Today, over 76% of Yemeni men carry this single paternal signature. That's not population diversity, that's a genetic monopoly. And when researchers from the 2024 Nature study compared Yemen's Y chromosome variation with 52 other populations across the Middle East, one thing stood out. Yemen wasn't just similar to its neighbours. It was more concentrated, more uniform, more locked in time. So where did J1 come from? Its roots lie further north, in the southern Levant, roughly 9,500 years ago. Among early Semitic-speaking pastoralists, likely in what is now Jordan or southern Israel. These weren't kings or priests. They were tribal men, herders, desert navigators. They moved south over generations, carrying herds, language and their Y DNA with them. And when they reached Yemen, something happened. Here, among mountains and deep valleys, they found not cities, but tribes. Tribes that valued purity of bloodline. Patrilineal descent wasn't just tradition, it was law. Names, honour, inheritance, all passed through the father's line. And with every generation, this tribal code acted like a funnel, amplifying J1 while other male lines vanished. genetic bottleneck, social selection, elite consolidation. By the time of the Sabaean kingdom, around 1000 BCE, J1 had already become the backbone of Yemeni tribal identity, and by the rise of Islam in the 7th century CE, it was untouchable. But the contrast is stark, because while the female line tells a story of trade, slavery and mixing, the male line is a wall. Unbroken, repeating, and that raises a question science couldn't ignore. Was Yemen's male ancestry always this uniform, or is there a rupture, a hidden exception? But in one region this pattern breaks apart, revealing a timeline from the Bronze Age. That region is Marib, a city half buried in sand, half whispered in myth. The ancient heart of the Sabaean kingdom, once ruled by queens and astronomer priests, now reveals something far older than temples or inscriptions, a genetic fossil still alive. Because when geneticists sampled tribal populations around Marib, not the cities but the highland strongholds, they didn't find chaos. They found preservation. Inside these genomes, something remarkable appeared, a near-perfect match with Bronze Age Levantine ancestry. We're talking Natufian roots, R0A maternal lineages, and dominant J1P58 paternal signatures, all concentrated, undiluted, locked in place for nearly 3,000 years. In modern terms, this is what scientists call a genetic time capsule. Unlike Yemen's coastal zones, Xi'an, where centuries of trade, empire and African gene flow shaped a melting pot, Marib resisted, not by force, but by code. Tribal law, marriage restrictions and oral lineages acted like a genetic firewall. Outsiders didn't mix in, they didn't belong. It's not just DNA, it's identity. Even today, many Maribi families trace their descent directly to ancient tribal names, inscribed in Sabaean stone: Kataban, Saba, Himyar, names that once ruled incense roots and warred over moon gods. And here's what blows the case wide open. In a 2023 comparative study by the Max Planck Institute, Marib's DNA showed closer affinity to Bronze Age Amorites and Arameans from modern Syria and Jordan than to the coastal Yemenis just 200 miles away. That's how isolated it stayed. Same peninsula, different genetic world. But this wasn't an accident. This was a conscious wall, one built over millennia, against change, against fusion, against time itself. And while Marib preserved what was ancient, coastal Yemen tells a different story, one shaped by sails, spices and slavery. A story carried by winds, by music, by mothers who came ashore, and by the genes they carried with them. Those genes didn't just drift in, they came on tidal waves of commerce, empire and human cargo. Because starting in the 12th century, Yemen's Red Sea ports became the epicenter of something massive. Not a war, not a conquest, but a migration explosion hidden in plain sight. By the time the Rasulid dynasty took power in 1229 CE, Yemen's coasts were breathing with movement. Hadramaut, Al-Hudaydah, Aden, these weren't backwaters. They were at a crossroads, where Indian Ocean trade met East African kingdoms, where Bantu sailors and Indian merchants docked beside Yemeni imams and scribes. But the genetic legacy they left behind is undeniable. In 2020, researchers using full autosomal sequencing dated a surge of African admixture in Yemen to between 1190 and 1290 CE, perfectly overlapping the Rasulid Golden Age. Today, in coastal populations, up to 30% of DNA traces back to sub-Saharan Africa. And the maternal line tells an even sharper story. Mitochondrial haplogroups L0, L2, L3 dominate, especially in the Red Sea Belt. That's not a memory, that's inheritance. Generation after generation, passed by women who crossed oceans and rerouted in Arabia. But it wasn't just DNA. Swahili loanwords slipped into the dialect. Bantu rhythms changed the beat of Yemeni songs. Even the food transformed. Tamarind, cardamom, fenugreek, all arrived by dhow, not camel. This isn't a side chapter. This is a genetic frontier, shaped by monsoon winds and market demands, and yet it has a limit. Because east of these melting pots, something strange happens. The African signals drop, the Indian markers vanish, the coastal fusion ends. There's one place in Yemen that refuses to be part of this story. An island forgotten by time, a genome untouched by trade, a language unbroken by empire. That island is Socotra, and in every way that matters, it doesn't belong to our world. Because while Yemen's coastline was shaped by African rhythms, Indian genes and Arab trade, Socotra stayed still, a floating relic, untouched by the monsoon, immune to empire. Genetically, it breaks every expectation. Autosomal analyses show that the people of Socotra have almost zero African admixture, a statistical outlier in a region where such ancestry is common. While the Red Sea coast holds 20 to 30% sub-Saharan components, Socotra barely registers any. It's like a door was shut and never opened. And that's not all. On the Y chromosome, they're not dominated by the Levantine J1 like mainland Yemen. Instead, they carry high levels of J2, a lineage associated with Neolithic Anatolia, northern Mesopotamia, and ancient Aegean trade networks. Their mtDNA, overwhelmingly R2, a maternal haplogroup nearly absent from the Arabian coast, but found in isolated Indo-Iranian groups, suggesting a founder event likely around 3000 BCE, when a small population landed here, and never left. And then there's the language. Socotri is not Arabic, it's not even close. It belongs to the modern South Arabian languages, descended from a prehistoric Semitic branch far older than Quranic Arabic or Sabaean script. Some linguists believe Socotri is the oldest surviving spoken Semitic tongue, still passed down entirely through oral tradition, never fully written. But here's the twist. The people speak of things science can't date. They tell of sea people who vanished into coral caves, of jinn who live in limestone spires, of a time before Islam, before writing, when the island was ruled by forces that didn't come from this world. Ruins still dot the cliffs, weathered monoliths, pre-Islamic graves, altars pointing away from Mecca. Even the island's flora and fauna belonged to a time before contact, with a third of its species found nowhere else on Earth. Socotra isn't just genetically isolated, it's culturally and linguistically suspended in prehistory. But what if there's a reason for that silence? Because when we test the DNA further back, to the most ancient markers, to the oldest signals of humanity itself, we find something even stranger. These people aren't entirely human either. Because inside every Yemeni genome, tucked between the markers of tribes, empires and mothers lost to time, is something older. Something not fully Homo sapiens, something Neanderthal. When scientists sequenced modern Yemeni DNA, they found what they expected: fragments of ancient human migration, Semitic markers, African flows. But buried deeper, across every sample tested, appeared a shared signal. Roughly 1.8 to 2.2% of every Yemeni genome comes not from Africa, not from Arabia, but from a now extinct cousin species, Neanderthals. But here's the twist. This percentage is lower than what we see in modern Europeans or East Asians. And that's where the real story begins. Because Neanderthal admixture didn't happen in Yemen. It happened before. Long before. The encounter took place somewhere in the Near East, around 55,000 to 60,000 years ago, when Homo sapiens left Africa for the first time and ran into another kind of human, broad-faced, fire-skilled, powerful, Neanderthals. It wasn't war, it was interbreeding, short-lived but permanent. And when that hybrid group moved on, through the Levant, across the Sinai and finally into Arabia, they carried with them fragments of Neanderthal DNA that still survive in modern Yemeni blood. We're talking about immune system enhancements, resistance to ancient viruses, even metabolic traits that affect fat storage and skin adaptation, things shaped in Ice Age Europe, but still subtly active in the sandstorms of Yemen. A 2021 genome-wide study confirmed it. The Yemeni Neanderthal segment closely matches the Bedouins of the Levant, not the Anatolians or modern Arabs of the Gulf. That's an ancient tie, a ghost bond, to people who no longer exist, but whose cells live on. And it's more than science, it's personal, because it means the people of Yemen, in the highlands of Marib, the ports of Aden, even the caves of Socotra, carry in every drop of blood a trace of someone not fully like us. But here's what no one expected. When scientists compared Yemeni DNA against modern populations, something strange happened. Their genes didn't just match Arabs or Africans or South Asians, they began to mirror something older, something deeper. And then came the moment no one expected. Inside the Yemeni genome, buried beneath layers of Semitic migration, Neanderthal shadow and African tides, scientists found something that didn't match anything. Not Indian, not Levantine, not African, not Persian. It was a signature, a genetic code, found nowhere else. It appeared first in maternal lineages. Deep sequencing of mETDNA R0A revealed a cluster of sub-branches, especially R0A1A. Ancient, yes, but not like the others. This wasn't a lineage passed down from a common Middle Eastern source. This was hyperlocal, concentrated and unique. In isolated Yemeni tribes, especially those in Hadramaut and Al-Mara, these subclades didn't just survive, they evolved. Under centuries of pressure, heat, humidity, malaria, waterborne bacteria, even tuberculosis, their genomes adapted, and left behind traces of that adaptation in the form of rare SNPs, single letter changes in the DNA code, subtle but powerful. Several of these SNPs are not found anywhere else on Earth. They appear only in Yemen, passed down through tightly knit populations, likely shaped by centuries of environmental stress and genetic isolation. And here's where it gets extraordinary. Some of these SNPs sit in regions of the genome linked to immune system regulation, iron metabolism, and cellular resistance to oxidative stress, the same mechanisms that combat malaria, defend against tuberculosis, and regulate blood oxygen in high-altitude environments. This isn't myth, it's measurable. In 2023, a study from the University of Tartu found that Yemeni populations in high-risk zones displayed natural genetic resistance to common regional pathogens, not because of recent vaccines or antibiotics, but because of inherited molecular defense systems that evolved over thousands of years. Think about that. Some of the world's rarest and most targeted disease adaptations aren't in hospitals or databases. They're locked in the DNA of forgotten mountain tribes in southern Arabia. And that leads to one question no one has answered. How did this stay hidden from global science for so long? Who chose to look away? And what else lies inside the genome that no one's dared to decode? To answer that, we have to stop looking at the lab bench and start looking at the land. Because Yemen's greatest genetic secret wasn't hidden in complexity, it was hidden in isolation. Here's the contradiction. While most ancient regions were devoured by the empire, carved up by Caesars, sultans, shahs, Yemen was never fully conquered. The Romans tried. They called it Arabia Felix, Fortunate Arabia, and sent legions to secure the incense trade. But they never passed the mountains, not even close. The Ottomans ruled for centuries, but only from the coasts, inland in the highlands, in Sada, Marib, and Jabal al-Akhdar. It wasn't the empire that ruled, it was a tribe, and the tribe has a different memory. While empires burned libraries and rewrote names, tribes preserved them, orally, repetitively, generationally. You didn't need a birth certificate. You had your father's voice, and his father's, and his. But that memory didn't just survive in stories, it survived in DNA. Because in tribal Yemen, especially in the highlands, endogamy wasn't taboo. It was sacred. Marriage outside the lineage was rare. Outsiders were strangers, and sometimes even forbidden. And while the world changed, colonized, globalized, digitized, Yemen's highland tribes stayed genetically unmixed. That's how J1P58, R0A, and rare SNP patterns remained almost untouched. That's how populations in Yemen still show genetic continuity with Bronze Age Levantines, when nearly every other ancient gene pool on Earth has been overwritten by war, trade, or assimilation. It's ironic. The same political instability, fragmented governance, and geographic seclusion that make Yemen a failed state on modern maps also turned it into a genomic time capsule. Empires erased borders, but Yemen's tribes remembered blood, and yet. This memory is under threat, and time is running out. Globalization is here, climate change is moving fast, and what survived 3,000 years of resistance may not survive the next 3 decades, because beneath the threat of collapse lies something that may be humanity's original heartbeat. Not a symbol, not a metaphor, a literal map of where we began. In 2015, a large-scale genetic comparison across East Africa and Southern Arabia led researchers to a startling pattern. Certain mitochondrial lineages, especially L6, M1, and early branches of haplogroup N, didn't follow the usual diffusion path expected from African migration. Instead, they clustered in southern Yemen. Why? Because around 60,000 to 70,000 years ago, early Homo sapiens left East Africa, crossing what was then a shallow land bridge at Bab el-Mandeb. But they didn't all move on to Asia. Some paused, some settled. Archaeological data from the Wadi Sedud Basin and the Tehama Plain shows continuous human presence stretching back tens of thousands of years. No signs of reset, no signs of reinvasion, just slow, stable, ancestral life. The DNA matches the soil. Autosomal traces Y-DNA J2 and mtDNA R0A and L6 in today's Yemenis form what scientists now call a genetic relic population, groups that retain the oldest surviving configuration of Eurasian ancestry. Even more striking, these lineages show limited admixture despite centuries of outside contact. This makes them rarer and cleaner than similar signals in Ethiopia or the Levant. In 2022, a research team from King Saud University and the Max Planck Institute published findings that certain Yemeni highland populations are the closest living analogues to the genetic makeup of the early Eurasian expansion. This isn't just a bridge, it might be the route. So when we ask, where did we come from? We're not just talking about maps, fossils, or theory. We're talking about living descendants of the very first wave, still speaking, still remembering, still walking the land their ancestors first touched after Africa. Yemen was never just a crossroads. It may be where the journey began and where it still lives. And now we have to ask, will we protect that memory or watch it disappear, one genome at a time?